Hey, how's it going? Today I'm going to go over one of the daily questions on Leetcode, number 2529, maximum count of positive integer and negative integer. Um, so I'm going to go through this problem and sort of treat it like if I was asked this question during an interview. Yeah, I haven't done this problem yet, so it would be a fresh perspective. Yeah, and hopefully this helps out. Okay, so let's go through the problem first. Given an array nums sorted in non-decreasing order, return the maximum between the number of positive integers and number of negative integers. In other words, the number of positive integers is nums is positive, and the number of negative integers is neg. And then return the number maximum of pos and neg. So neither are 0. Okay. Oh, 0 is neither positive nor negative. Okay. So there are 3 and then 3 positive. Okay, that makes sense. There's 3 negatives and 2 positives. So 3. Okay. So I guess how I could potentially go about this problem would be more of like a just iteration and then just storing the results into like another data structure. That could be a potential solution. Let's see if there's like another way that we could do it. Can I do this without using any extra space? Well, I could determine which one the max is without using any extra space, but or I guess I would be using constant space for that problem. Okay. Anyways, let's try to just do it in the way that I was talking about before. And maybe we can find some sort of way to optimize it. All right. So first, I'm going to just have let pos, and this will be 0. Let neg be equal to 0 as well. And these will just be our holders for the numbers that we find. So we'll do a for loop for a const n of nums. This is just a iterator, and then we'll do if n is less than 0, then we'll do neg plus plus. Else if n is greater than 0, then we'll do a pos plus plus. Yeah, I mean, that's kind of basically it. You just do that, and then you can just do a return math.max pos and neg. I'm pretty sure that would work. I don't think I need to do anything else. Yeah, so I mean, this problem is pretty straightforward for the most part. I feel like, yeah, there's probably like a faster way to do it. I'm not seeing immediately, but we can try to go through that very briefly. And I think the big thing to just note here is just looking at the conditions, because I'm not trying to include 0, because 0 is indicated as neither negative or positive, so we don't want to do anything with that. And then if you know about using different libraries, so here I'm using math, and I'm able to use the math.max to get the maximum of both these values. So that makes it a lot simpler for me to write out at least. So yeah, and then this will just run order n for time complexity. Space complexity would be constant because I'm just using constant space. Or just like, yeah, I mean, single variables to hold the results. Yeah, let's try to think of a way to optimize this. So if I wanted to, are these sorted? Sorted in non-decreasing order. Oh, okay, so there's potentially a binary search solution here. So let's try to think of that. So, oh, is there a binary search solution? I feel like what it comes down to is, say I go start at the middle. But then we have zeros that could mess it up. No, I feel like binary search is definitely a possible solution here. Let L equal 0, let R equal nums dot length minus 1 while L is less than R. And then we'll do let mid is equal to math.floor of L plus R divided by 2. So this is just like pretty standard binary search algorithm. I recommend you learn it on your free time. It will help with like a lot of different things, because when it comes to different algorithms where it's supposed to run log n, most of the time this could be a solution that will help you out. Okay, anyways, so now we have our mid. What's our condition here? If mid, oops, nums mid, this is equal to, there's two possible things here. We could have mid equaling, so if mid is greater than 0, and nums mid, so positive numbers will always be on the right. So that means we're going to do a decrement. So mid is less than or equal to 0. That means we found the leftmost positive number, but that leftmost positive number has to be greater than, so here we could do, oh, so I guess what we could do here is two different binary searches, both of them which would be running log n. And is this really easy? Okay, I feel like this is like this solution that I'm trying to do is definitely a lot more difficult. But I mean, I guess I can try to go through it and see if it works. All right, so yeah, continuing on, if nums mid is greater than 0 and is, or this nums mid minus 1 is less than or equal to 0, that means that index is where the max is. So we can do also, I guess with similar setup to before, we'll have these different variables and then we'll do a max of both. So since this one's looking for a positive, pos will equal mid, sorry, not mid, we'll do nums dot length minus mid, I believe. So the logic here would be, say we find this index here, 0, 1, 2, 3, and then 5. So it would be length 6 minus 3 if we find this one, which is, we have the length of 3. So we're good on that. Else if we have nums mid is equal to, actually, I guess in this case I could just do nums mid is less than or equal to 0, then we need to move our left pointer, ideally. So then L will equal mid plus 1. Oh yeah, I tend to like to do less than or equal to include the other cases. And then this one will be if it's greater than, or so if mid is greater than 0, then our we need to move our right pointer to find the max. Sorry, mid minus 1. And just to make sure that this makes sense, so if I have my left and right, so we have 0, 1, 2, 1, 2, 3, 4, 5, 6. Length 6. 6 minus 1, 5. So we have 5 plus 0. So the middle of that will be 2.5. Well, we're getting the floor, so it'll be just 2. So then we'll start at this index here. And we'll have, if mid is greater than 0, which is not, so we won't even go to that condition. So mid is less than or equal to 0. That means our positive is going to be on the right side. So we'll do left is now equal to mid plus 1. Meaning it'll be on index of, I think that's 3. So then L, now we'll be looking at this subsection, and then we'll do a similar thing here where we're checking the middle number, and then since the number next to it is not less than or equal to 0, then we could move on to the next case. If nums mid is less than or equal to 0, then we'll do move L, but in this case it is not, so we'll move R down. So we'll have mid and then R plus 1s, and then we'll finally check this one here, and that's how we'll get our positive number. So that's found by this way. But the only thing is we need to perform the same operation to find the negative one. So the logic will be slightly different. It'll be mid is less than 0, and mid plus 1 is greater than or equal to 0. The only thing is if it's on the edges for some reason, then that could make it a little bit wonky. But I guess this one, so if nums, what if it was all positive numbers, right? And I did this thing. If I'm looking for negative, I'm going to go through and eventually we'll get to zeros. So then we'll do, if mid is less than, so we'll do R minus 1, or mid minus 1. Then our negative would just be 0, meaning if we do the getting the max of it, it should still turn the same result. Math.max of neg and pos. But this logic is slightly messed up here. So if, oh yeah, and also this is also incorrect as well. This would be equal to just mid, maybe? Plus 1, I think. So we find 0, 1, 2, that's a length of 3. So yeah, I would do a mid plus 1. So that's where I would go. If I find this case here, negative 1, then mid is going to be equal to this 0, 1, 2. Mid will be equal to 2, I believe. 2 plus 2, 4 divided by 2 is 2, yeah. And then if I wanted this index, since there's 0 indexing, that's why we're adding 1. And then for this conditional here, I need to fix this one. Positive would be 1 here. If I do a 1 here, then I also return a 1. So I mean, I could add this extra condition where and nums mid, or sorry, yeah, nums mid is less than 0. So these are the two conditions that could potentially go through. And then I would need something similar to here. I think that would work. So then this one needs to be greater than 0 strictly. And it works, and that makes it significantly faster than what we had before. I don't know by how much, but I mean it's a whole 1 millisecond. And yeah, I hope that sort of makes sense on how I came to that kind of solution. Yeah, if not, feel free to let me know and I can try to make a revision. But the idea was mainly just to do binary searches, and this optimizes, or this makes our solution more optimal due to the log n runtime and yeah, constant space used as well. Alrighty, that was a long video. Thanks for watching. Feel free to leave a comment, and I'll see you for the next one. Thanks for watching. Bye.